Hello, everybody. So what you guys are going to be doing now is working on simplifying radicals. A radical is a term for this symbol. It's generic, okay? I know you have, so that would be a square root. I know you haven't seen them yet, but this would be a cube root, and this would be a fourth root. Don't worry about these right now. I'm just letting you know that a radical implies to all of these symbols. We're only going to be working with this one, so don't sweat it, okay? I'm just giving you more information than you need, but sometimes that's good. Okay, I want to simplify it. So how you approach it is, I'm going to look at things that multiply to 28, like 2 and 14, or 4 and 7. If I break this apart in the square root of 2 and the square root of 14, nothing's going to happen. It's still the square root of 2 and the square root of 14. Now, what do I mean by that? Let's say you have the square root of 9. Don't you guys know that that's 3? Or the square root of 4, you know that's 2, or so on. The square root of 25 is 5. These numbers are called perfect squares. These numbers are perfect squares because they square root completely. Square root of 28 doesn't square root completely. If I break, and you can break this apart into two roots that are a product. Neither of those are like these. They're not going to simplify. But this one, square root of 4 times the square root of 7, the square root of 4 you know is 2. 2 times the square root of 7. That's your answer. Now, trust is good. It's good to see it, okay? So let me show you that you can actually, that this is legal to break it, okay? So the square root of 28, let's look at that one. Let me clear this up first. Square root of 28 is that decimal. Now I said this product is still worth the square root of 28. So the square root of 2 is going to come out times the square root of 14. And when I hit enter, if it's the same as the square root of 28, it should give you the same decimal. And it does. Likewise here, the square root of 4, come out of it, the square root of 14, oops, sorry, wrong number. So let me delete that, put 7, okay, it's these two, enter, gives you the same decimal. And to further prove it, let me go 2 times just the square root of 7. Gives you the same decimal. So this is still worth that, okay? So let's try 63. Hoping you guys jump to 9 times 7 is 63. Split it into two separate roots. Square root of 9 is 3. The square root of 7 is still there. Done. Okay. 50. What you're looking in your head is to try and find perfect squares. Like 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. You go, whoa, wait a minute. 2 times 25 is 50. So if I broke it, square root of 2 doesn't simplify, but 25 does. And this number needs to be written in front. It goes 5 square root of 2. That would be your final answer. Okay? Any simplified numbers belong in front of the root. Okay, 162 is a little harder. I'm going to start dividing it by 2. 2 times, so I know I'm not using these. I'm just like, okay, let's get it something smaller so I can start to see it. Okay? 2, when you type it in your calculator, divide it. So 162 divided by 2 gives you 81. You go, oh, wait a minute, I recognize that one. Square root of 2 times the square root of 81. Square root of 2 stays 9. And that 9 has to be written in front. 9 root 2. Okay. 72. Not sure I see it yet, so I'm going to just try dividing by 2. 2 times 36. Perfect. 36 is the perfect square. So square root of 2 times the square root of 36 is square root of 2 times 6, or 6 root 2. Okay, 108, I don't see it. I'm going to try dividing by 2, see what I get. So I get 2 times 54. I still don't see a square. So I'm going to divide this again. 2 times 2 times 27. Oh, there we go. So I got 4 times 27. But doesn't 27 break out again? Isn't there a perfect square hanging out in 27? 2 doesn't fit. I divide it by 3, I get 9. There are 2 perfect squares. So I got the square root of 4 times the square root of 3 times the square root of 9. This one simplifies to 2. The square root of 3 doesn't. And that one is 3. Now these are all products. This 3 needs to come in front. So it's 2 times 3 times the square root of 3, or 6 root 3. Okay? You have to fully reduce it. If you left it here, square root of 4 times the square root of 27, and got 2 root 27, it's not done because there's still a perfect square hanging out inside there. So you have 2 square root of 3 times 9. The 9 is going to be a perfect square. And so you back to the 2 root 3 times 3. It's a product for all these things. That 3 has to come in front again, so 2 times 3 times the square root of 3, or 6 root 3. Okay? And some of them are going to be just easy like this, which is just 5 and you're done. Okay? That's the name of your assignment. Let me know how I can help.